If you look at the sky after sunset, you'll see this bright speck of light. You may call it a star, but it's actually a planet. This is Venus. Let's observe Venus through a couple of eyepieces. One of them is a 25 mm Plossel eyepiece, and the other one is a 6 mm wide angle eyepiece. This is the live view of Venus through the 25 mm Plossel eyepiece, and as you can see, it looks just like a diamond. But you know what? It looks better with higher magnification. Let's put in the 6 mm. This is Venus through the 6 mm wide angle eyepiece, and if I decrease the brightness, the phase becomes slightly visible. Wait, what? Phases of Venus? Yes, Venus actually changes shape, just like our moon. When you look at Venus through a telescope, you don't see a full circle like any other planet. Instead, you see phases, crescents, halves, or even something close to full. But how can a planet change shape? The answer lies in where Venus is. Venus orbits the Sun inside Earth's orbit, so as it moves around the Sun, we see different portions of its sunlit side, exactly like we see the phases of our Moon. Here's where it gets really interesting. When Venus is closer to Earth, it looks bigger, but only as a thin crescent, and when it's farther away, it looks smaller, but more full. That's why sometimes Venus looks incredibly bright in the sky, even when it's just a glowing crescent. And once you know this, you'll never look at the bright star in the sky the same way again. Now the question arises, what makes Venus so bright? I mean, it isn't the biggest, but it's the closest. That doesn't complete the story at all because Mars and Venus are roughly at the same distance from Earth. The secret lies in Venus's atmosphere. Venus is completely covered by a thick, global layer of clouds made mostly of sulfuric acid droplets. These aren't like Earth's soft, patchy clouds. This is a dense, unbroken blanket that wraps the entire planet. And these clouds are extremely reflective. In fact, Venus reflects about 70% of the sunlight that hits it. That's more than any other planet in the solar system. This is known as reflectivity albedo, and Venus has a very high albedo because its cloud tops act like a giant mirror in space. The cloud particles are just the right size to scatter sunlight very effectively in all directions. This scattering makes Venus look bright and steady, almost like it's glowing rather than twinkling. And also because these clouds are so thick, they completely hide the surface of Venus. When is Venus at its brightest? You may expect that when it's highest in the sky, it would be the brightest. No, that's incorrect because Venus is the brightest when it is in its crescent phase, after its greatest elongations. Therefore, greatest elongation does not equal to greatest brightness. An American president, oh gosh, I forgot his name, claimed to have seen a UFO. Later, it was confirmed that it was probably Venus because it was so bright. That's how people have related this brilliant, bright planet to something very exotic. Because if you compare the other stars, like even the bright ones, Sirius, Arcturus, Canopus, even they aren't that bright. Venus is dazzling bright in the night sky. It glows with a magnitude of -4. And through a telescope, as you saw, it looks just like a diamond. Even in Roman and Greek mythologies, Venus is the goddess of love and beauty. But that's where all the beauty fades away because here we hit the extremes. The temperature. The surface on Venus is around 465 degrees Celsius. That's hot enough to melt lead. And here's the shocking part, Venus is actually hotter than Mercury, even though Mercury is closer to the Sun. So, what's going on? Venus has an extremely thick atmosphere made of 96% carbon dioxide, covered in dense clouds of sulfuric acid. This traps heat in a process called runaway greenhouse effect. And once this heat gets in, it never escapes. Although Venus's gravity is around the same as Earth, its pressure is 90 times that of Earth. That is like being 1 kilometer underwater, except that water is replaced with crushing toxic gas and extreme heat. Hidden beneath its beautiful atmosphere is its horrific landscape. The surface is covered in vast volcanic plains with thousands of volcanoes hidden beneath the thick clouds. We can only see them using radar. Venus isn't just extreme, it's a warning. It shows what happens when a planet's climate spirals out of control. Now let's dive into some advanced astronomy and talk about retrograde motion. Outer planets go retrograde. As you know, if you don't know retrogression, you can check out my video linked here. Coming back to retrograde. Outer planets go retrograde and they seem to be moving backwards or westwards through the constellations as seen here from Earth. But here's the cool fact. Even inner planets go retrograde. How is that? Let's take example of Venus and dive back into history. Well, not that historical, but okay. If you had tracked Venus over several months, you would have noticed that Venus was somewhere here and it rose here and then so on. It has been rising ever since. Venus will reach its furthest point in the sky, which is right here, on August 7th. It will make a perfect angle of 90 degrees with the sun, after which it will begin its retrogression and move into the eastern sky. Here are a few terms that I need you to know before the explanation of retrograde motion of Venus. The first one being greatest eastern and western elongation. Right now, Venus is in the west, which means it is at its eastern elongation. That's quite opposite, right? And when Venus goes into the eastern pre-dawn sky, it will be at its western elongation. In greatest eastern elongation, Venus will be at an angle of 90 degrees with the sun. And what will be the phase of Venus? That's right, it will be half lit because half the light is falling onto Venus and the other half is dark. After August 7th, Venus will enter its retrograde motion, swing into the eastern sky in about 2 months, and be at its greatest eastern elongation on January 5th. Venus takes around 584 days to reach at the same given point. But retrograde motion occurs faster, as you know, so it takes less time for Venus to swing from the western sky to the eastern sky, but takes a hell lot of time to go back into the western sky. That's a lot of information. Let's get into some more real observing. We have something which is called the planetary sweet spot, a Barlow lens. So the Barlow lens effectively doubles the magnification of whichever eyepiece you use. In this case, the 6 mm, the magnification will be doubled, which means it will act as a 3 mm eyepiece. Guys, you've got to see this. That's it for the video. Congratulations for making till the end of it. I hope that you've learned something new about Venus. But there's more to learn. So click the subscribe button so that you'll get more such content about planets, astronomy events, meteor showers and stuff. This is Chaitanya saying goodbye.